Okay, welcome to the first online lesson that we need to do now that school has been cancelled. Today I want to have a look at turning forces. Up until this point we've been looking at speed, we've been looking at how you can calculate speed, we've looked at distance time graphs, we've looked at pressure inside solids, liquids and gases. However, now we need to start having a think about turning forces. So today's title, which you need to write in your books, is turning force. By the end of the lesson you should be able to tell me what the words pivot and moment mean. You should be able to calculate if a turning force is in something known as equilibrium, and you should be able to explain what centre of gravity is. So I am going to be using an online, on-screen even, chalkboard. The same rules apply as what we would have in lesson. You still need to use green for keywords and you still need to use red for important points. So let's have a look at this first learning objective. Can you define what the words pivot and moment mean? So our first keyword is the word pivot, P-I-V-O-T. And a pivot can be defined as a point around which a lever or seesaw balances. So a point around which a lever or seesaw balances. Okay, so it's the point around which a lever or a seesaw balances. Our second definition, which was on that first learning objective, is the word moment. Moment. M-O-M-E-N-T. Now we can define a moment as a measure of the ability of a force to rotate an object around a pivot. So we can define this as a measure of the ability of a force to rotate an object around a pivot. An object around a pivot. Now, moments depend on the force being applied and how far it is from the pivot. Now, that's really important, so we're going to add it underneath there in red. We can say that moments depend on the force being applied, so depend on the force being applied and how far it is from the pivot. How far it is from the pivot. So a pivot is a point around which a lever or a seesaw balances, and a moment is a measure of the ability of a force to rotate an object around a pivot. The moment depends on the force being applied and how far it is from the pivot. Now there is a calculation for moments. So if we can get a different colour to use, a moment, so M-O-M-E-N-T, which is measured in Newton meters, so capital N for Newton, M for meters, so that stands for Newton meters, so Newton meters is equal to the force being applied, so the force Force is always measured in newtons. We did speak about this a few weeks ago in lesson. Times the distance from the pivot. So the distance from the pivot. Now, distance from the pivot is measured in meters, okay? So a moment is equal to the force times the distance. The moment is measured in Newton meters, force is measured in newtons, while distance is measured in meters. So if we have a look at this as an example, our pivot is the middle part of the seesaw, okay? We've said that moments are force times distance from the pivot. So if I can just steal this diagram and we can refresh this. So just get a new one, make it a black background so it's easier to see. And we paste our image in. If we have a look at this diagram, we've said that a moment, so our equation that we're using is moment is equal to force times distance. Okay? If we want to work out the moment being applied by this man, we can take the force, which is 1,000 newtons. So we've got our 1,000 newtons here. So 1,000 newtons. We can take the distance from the pivot, which is shown here, 0.5 meters. So we can do 1,000 times 0.5 meters to give us a moment of 500 newtons per meter, or Newton meters, okay? So that gives us 500 Newton meters. Remember, it should be a capital N because newtons are named after Isaac Newton. If we want to work out the moment of the young girl, we can say that she is creating a force of 500 newtons, which is half that of the man on the other end. So we've got 500 newtons. And we can times that by the distance from the seesaw. So the distance from the seesaw in her case is 1 meters. So 500 times 1 gives us a moment of 500. 500 times 1 is 500. So we can say that the girl has got 500 Newton meters. In this case, the seesaw would be balanced because the turning point, the moments created on both sides around this pivot are the same. So this moment would be the same as this moment. Okay? Now, I've got an example for you to have a go at. We can clear this. If you're not sure about this, reverse the video or pause it and make sure you've got your head around it. I'm going to refresh this screen. So we're going to refresh. We're going to make the background black again because it's easier for you to see. I'm going to paste this question in the top corner. Okay, if I can quickly remember how to make it bigger or smaller. There we go. So we have got a question that says a mother and daughter are on a seesaw 2 meters long. The mother has a weight of 600 newtons and the child has a weight of 500 newtons. Calculate where the mother must sit to balance the child who is sitting at the other end. Now, the equation that we have spoken about thus far is that a moment, and I'll try and colour coordinate it, a moment, which is always measured in Newton meters, is equal to the force in newtons So the force in newtons times the distance from the pivot. So times the distance from pivot. So distance from pivot, which is always in meters. I would like you please to pause this video now and have a go at that question in the blue box. While you're doing that, I'm going to have a swig of water. All right then, year 8. So you should have done this question by now, or at least attempted it. So what we've got is we've got a seesaw that is 2 meters long. That means that the seesaw must be 1 meter on one end and 1 meter on the other. So we've got 1 meter this side and we've got 1 meter that side. It's saying that the mother has a weight of 600 newtons. So the mother is applying 600 newtons to one end and the child is applying 150 newtons to the other end. It's asking, calculate where the mother must sit to balance the child who is sitting on the other end. So the first step you need to do is you need to calculate the child's moment. We need to do 150 times 1. So the force of the child, so first of all we'll work out the child. So child, their moment is 150 newtons. So 150 newtons times by 1 meter, because they're sat at the end, we're presuming they're sat at the end of the seesaw. That means that they have a moment of 150 Newton meters, because 150 times 1 is 150. The mother has a force of 600 newtons. Okay? We need her to get a moment of 150. We can rearrange this equation to find distance. So for the mother, we need to rearrange this. We need to swap moment for distance. If we do that, we need to have the moment divided by the force. So distance, to work out our distance needed, so distance from pivot, which is always in meters, or for this question is definitely in meters, we need to do the moment, which is in Newton meters, divided by the force. Which is in newtons. So using what we've got here, if I can quickly grab a calculator, to work out our distance from the pivot, we need to do 150 divided by 600. So 150 Newton meters divided by 600 newtons, to give us 150, quickly get my calculator, divided by 600, gives us 0.25. So she must be 0.25 meters from the pivot point. So the mom must be about here to balance the daughter who's sitting on the other end. Okay? If you're not sure about that, reverse the video and have a watch again. So, you should now, if we have a look back at our learning objectives, once I've refreshed the screen, you should now be able to tell me what the word pivot and moment mean. We now need to have a look at what we mean by the word equilibrium, okay? So this is talking about something known as the law of moments. The law of moments. So law of moments. Law of moments. Now the law of moments is an object is in equilibrium if the clockwise moment equals the anti-clockwise moment. So an object will be in equilibrium if the clockwise moment equals the anti-clockwise moment. Equals the anti-clockwise moment. So if that's a bit difficult to read, I'll read it out again. An object will be in equilibrium if the clockwise moment equals the anti-clockwise moment. So I want you to imagine that we've got a seesaw. So again, like we had in the previous question, we've got a seesaw with a pivot in the middle. If the force on one end, if the moment on one end, so if this moment is equal to this moment, so this is our clockwise moment, this is our anti-clockwise moment. If these are equal, the seesaw will balance, and therefore we say that it's in equilibrium. Okay? So we can always tell if a seesaw is in equilibrium by calculating both moments. So we can just say that we can tell if a seesaw is in equilibrium by calculating the moments. So we can calculate the moments to see if a seesaw is in equilibrium. Okay? So, you should now be able to tell me what we mean by the word equilibrium. Our final keyword and our final learning objective asks us to say what centre of gravity is. So our final part of this lesson, we need to have a look at the centre of gravity. Centre of gravity. Now the centre of gravity can be defined as the point in an object where the force of gravity seems to act. So the point in an object where the force of gravity, seems to act. Okay. Now, if the centre of gravity is to the left or right of a pivot, a turning force is made. So if we're thinking about the centre of gravity on this seesaw that I've drew at the top, so if I go a different colour, the centre of gravity initially is down the middle. So this is my centre of gravity, COG. If that centre of gravity is more to the right, a turning force will be created. If it's more to the left, another turning force will be created. So we can say if the center of gravity is to the left or right, is to the left or right, a turning force is made. A turning force is made. Okay? So if we have a look back at our learning objectives, you should now be able to tell me what a pivot and a moment is. You should be able to tell me what equilibrium is and how we can calculate it. And you should be able to explain what the center of gravity is. What I would like you to do now is I would like you to pause the video. I would like you to have a go at these questions. You need to write out these questions first, filling in the gaps. Then for question 2 and 3, I would like you to actually write out the question in your book before answering it. If you've got a green pen, it would be handy to have that with you, because in a moment you're going to press play on the video and we're going to go through the answers. So please have another colour pen, pardon me, ideally green. If you haven't got a green pen, any pen will do, or a pencil even, okay? Just as we would in lesson, we're going to go through the answers, we need to mark it, and you can make corrections as we go. Okay then, so you should have hopefully had a go at these questions by now. If I make this full screen so it's nice and big, and we can go through the answers. So the first one should have read, the turning effect of a force is called a moment. You can calculate the moment of a force by multiplying the force by the distance. If the anti-clockwise moment equals the clockwise moment, the object will be in equilibrium. This is the law of moments. The something of an object acts through a point called the center of gravity. So the pivot of an object acts through a point called the center of gravity. So this should read, the turning effect of a force is called a moment. You can calculate the moment of a force by multiplying the force by the distance. If the anti-clockwise moments equal the clockwise moments, the object will be in equilibrium. This is the law of moments. The pivot of an object acts through a point called the center of gravity. Question 2. A girl applies a force of 5 newtons to close a door. The handle is 0.75 from the hinge. Calculate the moment. You should have done 5 times 0.75 to give you 3.75. So you should have done 5 times 0.75 to give you a moment of 3.75 Newton meters. It is in meters, isn't it? Yeah. So 0.75 Newton meters. So the answer for the second one was 3.75 Newton meters. Finally, you needed to design a balancing game that children can play. You needed to explain in terms of the law of moments and how the center of gravity can be used to play it. So remember, you needed to have an idea where for something to be balanced, you need to have the anti-clockwise and the clockwise moments equal. You needed to have the center of gravity going through the middle of the object. Obviously, there's lots of different ones for that. However, if you referred to all of this, you would have got your marks. So 1 mark for saying that the center of gravity is the point at where gravity acts. If they are to be balanced, you need to have the center of gravity in the middle so that the anti-clockwise and clockwise moments are in equilibrium. You needed to also say that if the centre of gravity moves off to either the left or the right of the centre of gravity, it will no longer be in equilibrium and therefore the object would be off balance. So, you should have now had a go at all these questions. You should have marked them. If you haven't, you need to reverse the video and make sure that you have. But now you should be able to tell me what the words pivot and moment mean. You should be able to tell me how to calculate a turning force and see if it's in equilibrium. And you should be able to tell me what the centre of gravity is. If you have any questions about this lesson, please either reply to my post in Google Classrooms or drop me an email and I will do my best to answer them. Please keep all work in your book. The next lesson will become available to you on Google Classrooms when you are timetabled to have me next. So, I will see you then. Thank you very much.